Hey guys, let's do an example in this video of those cubic functions. We'll start off by saying f of x is equal to negative x plus 1 cubed plus 8. Let's find our stationary points and let's talk about the nature. So let's write this down. We start off by saying the function of x is equal to negative x plus 1 cubed plus 8. We then want to break this down. We say negative x plus 1, and then we'll do the squared version, and we'll say x squared plus 2x plus 1 plus 8. From here, we now need to look at putting that negative sign and multiplying the left side into the right side. So we have x cubed plus 2x squared plus x squared plus 2x plus 1 plus 8. Let's group our terms together. You can see you've got your negative x cubed, you've got 2x squareds, so that'll be plus 3x squared, but because the negative becomes minus 3x squared. The same goes for the x and the 2x, which becomes minus 3x, and that plus 1 becomes a minus 1, so you'll have 8 minus 1 makes 7. I'm writing it down here as you can see. So now let's do stationary points. We take the first derivative, we make it equal to 0. Because as you know, the first derivative is either positive or negative if it's gradient, and if it's equal to 0, no, it's a stationary point. We see that we get minus 3x squared because you take the minus x cubed and bring the 3 down. We do our first derivative as normal. So now we take the derivative, divide everything by 3, and we get the answer as we see in red. We then put our system in brackets, get rid of the negative sign essentially, and we separate. This means that x is equal to minus 1 because both of them are equal to minus 1. We say that f of x is equal to negative of x plus 1 cubed plus 8. And when the function where x is minus 1, we plug it in, we say at f of minus 1 we equal 8. So at the point minus 1, we have the y coordinate 8. Easy game. So that's our stationary point. And so that's either going to be a local minimum or a local maximum. It could also be a point of inflection, but in this case it'll be a minimum or a maximum. So now let's take our first derivative. We know that it's less than or equal to 0 because of the negative sign. We know that means on the left hand side we have a negative gradient. As you can see, I've written this. Right, so the function is negative and the derivative does not change sign at minus 1 and 8. So this isn't actually a point of inflection. So there we go, a little bit of a trick.